So we're going to be looking at the normal distribution here, which you might remember from year 12. The distribution of natural objects is often what we look at with the normal. So things that occur naturally, such as comparing the heights of sunflowers or the heights of year 12s or something. Normal distribution is all about continuous variables because it has to do mostly with measurements. So conditions for normal. We want to make sure our data is continuous. And things that are continuous are sometimes things like measurements, such as weights or heights, etc. And we want to make sure that most of the data is around the middle values, near the mean, and then there are a few outlying extremes, and that's kind of something you can think about with heights. Everybody kind of fits around the middle. Most people are around average height, and then there's a few really tall and a few really short people as well. And as before with Poisson and binomial that we've looked at, there's a couple of formulae that are rather complex, and you might not need to deal with that much unless you go on to some of the higher level stuff, but be aware of it. This Z value is one that a lot of you guys will get into a little bit, and this is describing how many standard deviations from the mean a particular weight is or a particular value is. So it tells you how far away from the middle you are with a particular value of x. And this is sometimes used to what we call normalize or standardize curves. Other things that we need to be aware of is that the bell curve that belongs with the normal curve has a total area, as you might expect, is equal to 1. So it's the whole area under the curve. And it's usually symmetrical. So this part over here would have an area of 0.5 because it's only half the curve. And your probability is calculated by finding the area under the curve between a set of limits. So between, we'll just say some values. So for instance, from the middle all the way out, or you can cut off another little piece like this and say what's the probability of getting values between like -2 and -3 or something. And that area there will give you the probability of that happening. Now, it does have a symmetry, and we are going to be talking a little bit about standard deviation, which kind of describes the variation or the spread of the data. So a couple of things to watch out for is that 68% of the data is within one standard deviation of the mean. So if the mean is right down the middle, one standard deviation to either side, so -1 standard deviation and +1 standard deviation, includes 68% of all the data. So for instance, 68% of the students at Rangi should be within one standard deviation of the mean if it was a normal distribution of girls here. And our next value, 95%, should be within 2 standard deviations. So that's the distance for 2 total standard deviations. Again, it can be above or below, but 95% of the data is going to be within there. And that goes back to the idea of the normal distribution having most of the values around the middle, and not as many out at the extremes or further away from the mean. And within 3 standard deviations of your mean, you should have 99.9% of the data included in there. So a really small amount of data or members of the data set, like apples or people, will be outside of 3 standard deviations from the mean. Other stuff that we want to pay attention to, again, like I mentioned, normal curves can sometimes be standardized, and this is something you guys won't have to do by hand if you're not fussed about it, because your calculator will do it all for you. But the Z value is basically taking any curve with any sorts of values and converts it. So if this, for instance, was the mean weight of bananas, and I had 250 grams as my mean weight, and a standard deviation of 20 grams. If I use this Z formula, again that will tell me how many standard deviations a given value is. So I can use that standard deviation formula to convert x and figure out how many standard deviations away from the mean it is. So if we say x is equal to 200 and say 75 grams, you can use that Z formula to figure out how many standard deviations away is 275 from the mean of 250. That would be equal to 275 minus the mean, which is 250, plugging in x and mu for the mean, all over the standard deviation, which is 20. So if you put that into your calculator, you should get 1.25. So what we're saying is that that value of x is 1.25 standard deviations from, so a z of 1.25 from the mean. And when you standardize, take every single one of these values and standardize it, you get a situation where you've got a mean of 0, and your standard deviation over here becomes 1. So it takes any curve, any normal curve at all, and normalizes it all, standardizes it all, so that it can be represented with a mean of 0 and a standard deviation of 1. And if you get it into that form, you can use the normal tables by hand, but your calculator will take it without it being standardized. So don't stress too much about that if you're in survival mode. So with normal, we have a few things that we need to define. We need a lower limit of the range, and that, for example, is kind of like finding here the lower limit would be -3 and the upper limit would be -2. I want to know what values am I looking at, and the lower limit is always to the left. It's always the bottom value, and the upper limit would be to the right of the range. And my standard deviation, this is basically your spread of the data. It tells you how much variation you've got within there. And another way to think about it is how much of the data differs. Maybe how much the data, sorry, not of, how much the data in the group differs from the mean. So how much variation is there from the average value, from that middle mean value? And the mean is usually what we think about as our average, one of many types of averages. And if you remember mean, that's the one that's calculated by add them all up and divide by the total number that you have. So the mean and the standard deviation are important. Our upper and lower limits, that's based on the question, what they're asking us. And we're going to use our calculator with those 4 inputs. So one thing to keep in mind is that, like Poisson, your calculator will tell you, and binomial, your calculator will give you an NPD and an NCD. But I want you to only use the NCD value. So again, that's in stat, normal distribution, or distributions normal, and then it's always going to be NCD. So probably good if we take a look at an example of how these different values come in, the LU, sigma, and mean. So a couple of steps that are helpful always for calculating a normal problem is to draw out a curve, label your mean and standard deviation, and shade in the appropriate area that you're looking for. So shade in the area that they're actually asking you about. So at an apple orchard, the mean weight of apples is 145 grams. I'm going to assume that it's normally distributed here, so my mean goes in the middle. 145 grams, that's my mean, with a standard deviation of 7.5 grams. By habit, most of us just write it off to the side with a standard deviation. And what is the probability of randomly selecting an apple that is between 150 and 160 grams? So the scale is usually kind of done in a way that makes sense, where the bigger values are over here and smaller values are over here. So if I'm looking for something between 150 and 160, well, that's going to be above 145. So I can just approximate here to here, maybe. and say that that's from 150 to 160. And that's the area that I need to calculate, because I want to know how many apples fall into that range of the distribution. And so I'm going to use my formula. And here I'm going to do in C, because it's always in C. The lower limit here on my left, the lower number I'm looking for is 150. The upper limit is 160. My standard deviation comes next, and that's going to be 7.5. And my mean is 145. So you put that into your calculator. Stat, distributions, norm, again, always use the CD. And my lower limit, like it's asking for, 150, 160, 7.5, and 145. So my lower, my upper, my standard deviation, and my mean. And my probability, it's not the z values there, but it's actually p for probability. So that is equal to, oops, didn't see it, 0.2297. So 0.2297. So in this case, if I go back to that orchard and randomly select an apple, I've got basically a 23% chance of getting an apple between 150 and 160 grams. So that's how we go about with solving the problems. So again, draw your curve, label the appropriate area that you're looking for, use your graphics calc to enter the data, and then interpret your answer. So in this case, that would be roughly a 0.2297 probability of an apple between 150 to 160 grams. So the next video is going to have more examples going through this, and there's a few little tricks to learn along the way. So feel free to take a look at that, or if you feel like you know enough, go ahead and get started. But I'd recommend watching the next one as well, because there are quite a lot of tricks. But some of you might remember all that from year 12 and not have any issues.